Hello students. In this lesson, we are going to discuss about the second part of addition to carbon-heteroatom, multiple bonds. In content, we will cover introduction, addition of organolithium, addition of Grignard reagent, addition of amines to isocyanates, hydrolysis of nitriles, formation of xanthates, and conversion of aldehyde to nitriles. Introduction. Formation of organic molecules is basically the formation of carbon-carbon single bonds, and one of the most convenient methods to do so is the use of organometallics, such as Grignard reagent and organolithiums. The organometallic reagents have metal-carbon bond, which is polar. The metal being electropositive in nature, imparts electron richness on the carbon directly attached to the metal in the organometallic reagent. The organometallic reagents are used as nucleophiles to attack on electrophilic centers. The polarity of a covalent bond between two different elements is determined by electronegativity. Let us understand this with the help of carbonyl compound, which is being attacked by organometallic reagent, that is, methyl lithium. In the carbonyl group, the oxygen is more electronegative than carbon, that makes the carbon of carbonyl group as electron deficient, and hence acts as an electrophilic center. In methyl lithium, lithium is electropositive and imparts electron richness on the carbon of methyl, which can attack as a nucleophile on the electron deficient carbonyl carbon. Thus, in organolithium, the organic part acts as nucleophile. Similarly, in organozinc, zinc is electropositive, but not as much as lithium in organolithiums, or magnesium in Grignard reagent. Addition of organolithium. As discussed earlier, lithium is a very electropositive metal, and the lithium-carbon bond is highly polarized towards carbon. So, the carbon in organolithiums is highly nucleophilic, which can attack on carbonyl group to yield alcohols, as the most common examples, as shown here. For example, addition of organolithium to formaldehyde gives primary alcohols, as you can see in the second diagram. When formaldehyde react with RmGBr, followed by hydrolysis, it gives 1° alcohol. Mechanism. In the first step, the organic part, that is, the alkyl group of organolithium, acts as a nucleophile and attacks on the carbonyl carbon, resulting in the formation of alkoxide. In the second step, on subsequent hydrolysis with water, the alkoxide gets protonated and results in the formation of alcohol, as you can see in the diagram. Addition of Grignard reagent with carbonyl compounds. Organomagnesium compounds are frequently called Grignard reagents after their discoverer. They are an important class of extremely reactive chemical compounds, which are used in the synthesis of hydrocarbons, alcohols, carboxylic acids, and other compounds. They are prepared by adding an alkyl halide to magnesium, being stirred in anhydrous diethyl ether, or THF. The magnesium get inserted between the carbon and the halogen. The carbon-magnesium bond, in Grignard reagents, is covalent, and not ionic. The bond, between the carbon atom and the magnesium, is polar. Carbon is more electronegative than magnesium, and so, the bonding pair of electrons is pulled towards the carbon. That leaves the carbon atom with a slight negative charge. The carbon-oxygen double bond is also highly polar, with a significant amount of positive charge on the carbon atom. So, the Grignard reagent can serve as a nucleophile, because of the attraction between the slight negative charge of the carbon atom in the Grignard reagent and the positive charge of the carbon in the carbonyl compound. Addition of a Grignard reagent to a carbonyl compound is a versatile reaction that leads to the formation of a new bond. The reaction can produce compounds with a variety of structures, because both the structure of the carbonyl compound and the structure of the Grignard reagent can be varied. A Grignard reagent reacts as if it were a carbanion. Attack of a Grignard reagent on a carbonyl carbon forms an alkoxide ion that is complexed with magnesium ion. Addition of water or dilute acid breaks up the complex. Here you can see Grignard reagent can readily reacts with formaldehyde. Now you will get the primary alcohols. For example, here, this particular butyl part of butyl magnesium bromide will attack as the nucleophile on the carbonyl carbon, which is electron deficient, and as a result, there is a formation of O- with MgBr+, which on hydrolysis will give you corresponding alcohol. Here you will get 1-pentanol, which is a primary alcohol. Mechanism: formation of alcohols via addition of Grignard reagents to aldehydes and ketones is carried out in two separate steps. Step 1, it involves the addition of the nucleophilic alkyl group to the carbonyl carbon, aided by Lewis acid. As you can see here, there is an interaction between Mgx+ and the carbonyl oxygen. The product of this step is bromomagnesium alkoxide. Step 2, it involves the protonation of the alkoxide oxygen, and the product of this step is an alcohol. Addition of amines to isocyanates. Ammonia, or primary and secondary amines, can be added to isocyanates to give substituted urea. This is an excellent method for the preparation of urea and thioureas, and these compounds are often used as derivatives for primary and secondary amines. See the example. Here it may be primary or secondary amine. When react with isocyanate, it gives derivatives of urea. Hydrolysis of nitriles. Nitriles can be hydrolyzed to give either amides or carboxylic acids, as you can see the reaction below. The amide is formed initially, but since amides are also hydrolyzed with acidic or basic treatment, the carboxylic acid is readily formed. Nearly all nitriles give the reaction with either acidic or basic catalysts. Formation of xanthates. The addition of alcohols to carbon disulfide in the presence of a base produces xanthates. The base is often OH-, but in some cases, better results can be obtained by using methyl sulfonyl carbanion. If an alkyl halide, RX, is present, the xanthate ester can be produced directly. In a similar manner, alkoxide ions add to CO2 to give carbonate ester salts. As shown here, when alcohol react with carbon disulfide in the presence of base, like NaOH, it results in the formation of xanthate. Conversion of aldehyde to nitriles. Aldehydes can be converted to nitriles by treatment with hydroxylamine hydrochloride and either formic acid or NaHSO4.SiO2 with microwave irradiation, as you can see the below reaction. Thank you.